Alrighty, you guys. So, picking up where we left off. Right here, yeah, we did not get very far at all. Lava features, or things you could make out of lava. I really, honestly, haven't been able to think of a better title in all these years. As I started to indicate with the two types of lava flows, how, imagine that plain old boring piece of basalt you guys saw in lab, how much cooler it might look if it was, the hoi hoi, perhaps, or the might not be too neat, but the hoi hoi all twisty and windy and everything. That would look kind of cool. So as it turns out, there's a whole lot of other artifacts, for lack of a better word, that are left behind with lava. A lot of other cool ways that lava can look, and we're going to talk about some of those. This is just monstrous. Columbia flood basalts. So there is another way that volcanic activity can happen, and I don't think didn't add a slide for this. So we're going to add a little premise here, not a premise, but a little insert here, and that's a fissure eruption. Fissure eruption, F-I-S-S-U-R-E probably, right? Fissure eruption, and that's when the Earth just kind of cracks open and bleeds. Fissure eruption would be when I was describing to you guys how way back when, not on day one, but day really, really early, the Earth's surface finally cooled, and all of a sudden it cracked back open again, and we had these giant, basically the plate boundaries, so on and so forth, and the Earth just outgassing started. Remember all that? So there wasn't big pointing mountains necessarily spewing out lava and all this stuff. It was just cracks in the Earth, and that's a fissure eruption, and that's actually very, very common. One of the things that happens with a fissure eruption then, or can happen, are flood basalts. All right, this happens to be a particular flood basalt, the Columbia flood basalt. There's more. There's the Deccan traps, which were over in China or India. If you read about the demise of the dinosaurs, the Deccan traps or the Deccan traps come into play, because they happened right around the same time, again, geologically speaking, right around the demise of the dinos. But so what's unique here, and I've been sort of chattering all those pictures up, and hopefully you've been staring at it, is all the way down to the bottom, to the end of that, trust me, very, very tall waterfall. Those are trees down at the bottom there, along the left-hand side, not shrubs. All the way up, all the way into the background, and you see a little set of spires again to the left of the waterfall. That's some stuff that Wile E. Coyote could fall off of and definitely go splat. All the way up to the top of the next plane there, if you would. All the way back into the background and all the way back, even still. And then put that on 3 more states. That's the Columbia flood basalt. All right. And it still wasn't that original event that we talked about. But this was just huge. The Earth cracked open, and she bled and bled and bled and bled for a very long time. Because it's igneous rocks, we actually could get a really good date on it. I just unfortunately don't know it. But igneous rocks, especially extrusive igneous rocks, give us really good dates. So we know exactly when this event happened. And yes, again, we would call something that's thousands of years here, we would call that an event. So flood basalt, right? It's just a massive outpouring of what type of rock? Basalt. Yeah. There you go. Chris, you had a question.
Yeah. Remember how on Tuesday we were talking about geysers?
Mm-hmm.
Is when the water shoots up, is the pressure enough from it to if you were standing on top of it to send you flying in the air?
Surely you've watched Yogi Bear before.
Yeah.
Yeah. No,
Like, are those real? Like, you could actually do that?
I'm sure it's not allowed. It's pretty damn hot.
I watched Ice Age last night
So.
and the mammoth did that.
Okay. Alrighty then. Yeah, we definitely don't go to Ice Age for scientific accuracy. Yogi Bear's a little better. Yeah, it's all about surface area. I mean, you get a good enough sized board underneath you, you could probably stay up there for a little while. But it's super hot. It's boiling. I mean, that's literally why it's blowing up, because it's boiling. So you would die. Even, the fall aside.
Oh, don't try it, never mind.
But yeah, the park ranger won't let you get anywhere near there, boo-boo. It's not going to happen. And that is the one thing I grumble about the tourists at Yellowstone. There's subtle, but there's fences everywhere. That will just kill you. The mud pots, again, all this stuff is there because it is boiling hot activity going on. All right, so yeah. Hollywood and science, especially geology, they do space much better than they do the Earth for sciencing. Anyhow, hell of a lot of basalt, okay? Massive amounts of basalt, and it came out pouring in one giant event. A lava dome. A dome you see in the bottom, it's basically a cork, okay? The lava on top, inside the crater, if you would, cools off. As you know, cooling leads to crystallization. And this is really sort of organic, if you would, not in it's alive or anything like that kind of nature, but it's a cork. Imagine if a champagne bottle, if the cork sort of grew out of the sides of the bottle and just sort of sealed itself over. It would be a pain in the butt to open, right? But boy, that'd be one hell of a seal. So that's kind of what's going on here. Is this dome, this cork grows right into place, which you might think is great. Hey, that volcano's done. No, it's not. Unfortunately, this is kind of bad because what this now allows, because it's quite frequently such a tight seal, it allows a lot of pressure to build up. Remember, we told you one of the big things with volcanoes, top three, okay, lava, gas, and pyroclastic material, all right, but the gases. So, again, the champagne bottle, the 2-liter bottle of pop or soda, I'm in New York, I gotta remember that, 2-liter bottle of soda, you shake that up, shake it up, at some point, that pressure is going to build up enough, it's going to blow that top. Well, what happens sometimes, and this is why it's really bad, is that this dome can actually be stronger than the side of the mountain, and it could blow out one of the sides of the mountain. And that's kind of what we had at with the St. Helens event. You'll see some slides of that later. Now, on one hand, that was good because it went out the top, like a big 4th of July firework kind of thing. It would have done a much different radius, but as it was directional, so it really sucked for the people on that side of the mountain. But overall, it was sort of better. The other thing, and we don't touch on this till the very end when we talk about gases some more. Volcanic domes can let one of the worst things, short of an actual eruption, happen, and like I said, we'll touch back on those in a little while. So we'll come back to dome briefly. All right, columnar jointing, as in joints that look like columns. Now, not the joints you guys are thinking of, but the joints as in cracks. All right, we see a handful of cracks all around there. And what you're supposed to understand at this point, I'll show you a picture in a moment, is that those cracks go all the way down into your formation. What comes to mind with me, for me with this stuff is string cheese. You know how you pull up these little strips of string cheese all around it? Okay. Because this is what, let's say, if you're standing on top of the string cheese, there is the side view. So what happens with columnar jointing, there's a slightly more famous string cheese there. what happens with columnar jointing is this part right here. The volcano itself was way above it. I've actually been here. I'm pretty sure this is my picture. It's so old that there's like no anything, you know, like in the files attached to it or anything like that. I was there. I kind of vaguely remember taking this picture. I told you about my ill-fated trip with my buddy back from Vegas. All around there were some signs, and I've got to find these signs. I recently found my slides. Back then, they were like, oh, don't take pictures, take slides. That way, you'll have them for your carousel for the classroom. Yeah, we see where slide carousels are. So I've got to scan them and so on and so forth. But somewhere around there, I took pictures of tons of the signs. And back to the point, the volcano itself was way above there. All right. All of these separate lava flows, this, that, and the other thing. Suffice it to say that in the end, the vent pipe, okay, way down low in the ground, kind of like we talked about that dome being so solid, crystallizing into place. All right, what was left in the vent pipe was way more durable than the volcano itself. So this is thousands of years of erasing, tens of thousands of years of weathering and erosion, wearing down this to the current land's position where we're standing taking these pictures and watching the prairie dogs. They've got a massive prairie dog colony that lives there, like thousands of them. So just all this weathering and erosion. So this is way deep down inside the earth. And now that there's nothing supporting that, it's finally, slowly breaking away itself. And what happens is once the pressure is removed from the side, it starts to crack like this. Why? It's a function of the crystallography, or one of the things we didn't talk about with igneous rocks kind of thing, okay? Just like anything you build out of Legos is going to be a function of those Lego shapes, right? You're always going to have those square edges. Well, nowadays you kids got round Legos, but you know what I mean. It's always sort of going to be blocky and Lego-y. And the same thing here. It's these planes. Think of it kind of like cleavage, when we talked about with minerals, how they break, okay? It's sort of like that. So this giant hunk of rock breaks into these, it gets these fractures, these vertical fractures. This is along the lines of telephone pole plus size. This is big stuff, big stuff. And like I said, slowly but surely you get this waste field around it as it breaks away and breaks down. This was added by a student not too long ago. This is a really cool place. Vaguely in the back of my head, I remember hearing about it. This reminds me of an ancient video game called Cubert over there, but in that one little corner there where you could bounce from one place to another. Very, very cool. I'm sure there's somebody on YouTube parkouring this nowadays or something like that. But again, you see all the hexagonal, and it is hexagonal. It's always six-sided. Okay, that is something to note. You get these hexagonal, telephone pole-sized shaped poles that just kind of fritter away. Story behind this in giants, I don't know. I'd better look that up one of these days. But that's very cool. I'd say arguably that's cooler looking than Devil's Tower. When I was growing up, everybody knew Devil's Tower because of Close Encounters of the Third Kind. It was a movie. And Richard Dreyfuss made this out of mashed potatoes. This means something. And in the end of the movie, that's what the spaceship landed on. Apparently they forgot their landing gear or something. I don't know. But, so yeah, that's... Back in the day, everyone knew that place. It's literally, and also, you've heard of like the middle of nowhere. This is the middle of nowhere. There are no highways within like 2 to 3 hours of this place. This is really where we just finally got fed up and said we're not seeing anything else on the way home. It's just too far away. Oh, I did want to do one more thing. A lot of people sit through geologist slideshows and fall asleep. We know we're boring. But they also get the impression that perhaps geologists are kind of sloppy because they're always leaving crap in the pictures. All right? You'll see camera lenses. You'll see pencils.
In most of Japo's slides, you'll see my foot. Like, oh my God, he's a horrible photographer. In this case, this poor guy forgot his hammer, right? No. Why is that hammer there? Scale. Oh, you guys are good. Yeah, it's there for scale. All right. Now, you guys knew it was there for scale. You may know this too. Those S-wing hammers only come in, well, first of all, it's an S-wing hammer because it's cool and it's got a blue label on it and a blue handle on it and that yellow label. Means it's S-wing. And they only come in 2 lengths. That's the short one. We know because how much silver we see. So we know that the radius of that rock is about that big. All right? And for those of you at home, I put my hand out about 14 inches or so. So no matter what, because I'm sure this guy also took, or gal, also took field notes, but they're never in the same place at the same time with your pictures. And also at every conference, they give us these cool little plastic rulers, nice big print on them, metric and American. You can see, it's great, but again, they're sitting on our desks. But we always got our rock hammer or something. So yeah, that's there for scale. So no matter when, where, how, or why someone's using this picture, they can tell you that you're looking at roughly, somewhere between 2 and 3 foot diameter for that thing. And for a geologist, again, that's good enough. Civil engineer, no. They want to know decimals and stuff. But geologists, we like to round. Proud of it. So case in point. Pesky tourist or there for scale? People kind of stink for scale. That's the problem. Because we're not all the same height. Looking at this person, I'd say, they're taller than me. But, you could go roughly 5 to 6 foot. Looking at their boots, yeah, they're a geologist. Because they got them buckskin 80s boots with the red laces in them. Those were the hippest of fashion back in the day with your puffer jackets. This is a lava tube. And this is also a great example of technology and teaching, and as a parallel, probably technology and science. I've been using this slide since 98, whenever I started teaching. And because it's a lava tube, and it's out of whatever book. Looks like it's from Plummer, McGeary, and Carlson. That's one of the company's books. And so this is Plummer's picture, and it's of a cool thing called a lava tube. Those paper yo-yos? They're wrapped and they're on a stick, and you go like this, and you get yelled at for poking your friend in the eye with them, or so on and so forth. Okay, those are what come to mind here. Also, the old Windows screensaver, which you guys quite probably haven't seen. It was a pipe building thing, and it would just keep adding little sections of pipe. You may have seen it on YouTube. I don't know. Well, what happens here, first of all, whether she is at the shoreline right now, I believe that's a she, or 3 miles up a mountain, we know that when this lava tube formed, it had to be underwater, because that's where lava tubes form. What happens is the lava flows into water. The outside of it instantly crystallizes, forming a pipe, if you would, as I was just talking about. And then as it flows, forms a new shell, and new shell, and new shell. And that's where that paper yo-yo comes to mind. That's where the pipe works, and then adding to itself on the screensaver comes to mind. It just keeps self-extending. So the inside then keeps flowing. And it leaves behind these cool little tunnels. I'm told there's some actually submerged, still submerged out there in the world, and they're kind of like the haunted houses of scuba diving. To go through these things, they're kind of, you never know what's going to be around the corner, and so on and so forth. So the real thrill seekers will go scuba diving through these things. But this one's obviously, on land. By the looks of it, I'd say it's pretty much still near the shoreline. It could have just rained, but the ground's a little wet. But back this little bit of rock back there and daylight and just the formations, it does kind of look like that shore rock back there. I don't know how I know. I just kind of feel like it is. So I'd say they're still near the shoreline. So here's the technology part of it. So when I first started teaching, I said, so you see that line right about their waist level, and that person appears to be staring at it and everything. I said, it's kind of hard to tell what's going on there, but more than likely we're seeing the effects of weathering and erosion. The water comes in, the water goes out, and over the years, even though it's igneous rock, it has managed to wear it down. And then one semester came along. I don't know if I actually moved from overheads to slides, I never really used slides ever. Probably from overheads to digital, and maybe even a new projector one semester. At any rate, I realized that that's a ledge, not an indentation all of a sudden. The resolution got so much better that you could actually set your coffee mug on that now. It always looked like an indentation before. So I had to come up with a story as to why there was that weird indentation. So now I have to come up with a story. You guys would never even notice if I hadn't pointed it out, right? But as to why there's that ledge there. And I got a couple. One of them, they may have actually sort of enhanced this for tourists. They might have dug out the bottom a little bit. But again, igneous rock's pretty freaking hard. And to dig that out without really destroying the top would be kind of hard. So what I'm thinking now is it was just a couple subsequent flows that weren't super strong. Didn't go all the way up, didn't fill the tube, and just sort of lined it with a little more gunk. But we'll never really know. It does kind of look like the roof was worked, but I'm not seeing enough lava tubes again to compare, and ones that were certifiably natural. So I don't know. Yeah.
Could it have been like water leaked through there at one point and it like left sediment to fall to the bottom?
If we could get there and see that that's sandstone or siltstone, most definitely. For now, we could call that a working hypothesis, totally. Except, no, I got to shoot it down. And you'll learn this when we get to the stuff on the walls wouldn't have stayed, more than likely. If it was flowing, running water, gravity would bring it straight down. But there could have been a huge event. Well, we could modify that. There was a huge event where, let's say, half of the bottom was filled up over a couple hundred years, couple thousand years with sediment. And then a river started flowing through it again, or a stream started flowing through it again, and wore out, because you could get it that way. So you could fill it up with sediment all the way to the rim, and then wear back down. So, still possible. Still possible. But otherwise, the stuff on the sides wouldn't stick. It's not like icing where we can kind of spackle it in. So, yeah. So lava tubes, at any rate. Lava tubes only form near water. And again, what's kind of the important part here is that this is a clue we could find in the rock. All right. And if you couldn't tell, I'm a little more chattery about this stuff. This is my end of geology. I do surface processes and critters, and we look. And I'm not trying to inflate it or anything like that, but like sort of Sherlock Holmesy or CSI kind of stuff. It's not just rocks anymore. There's clues in these rocks. You got to find them, and you're able then to reconstruct the environments where this stuff formed. And like I said, regardless of where this is now, we know that when this happened, and we could do that really great because it's extrusive igneous, so we could put a timestamp right on it. We knew that the water level was high enough there now to totally crystallize that as it flowed. So yeah. Well, that'll be a running theme. Similarly, pillow basalts. This guy has to be a geologist because probably no one else would notice those giant round things there. You guys would because you've sat with me now for a month and a half or so. But anybody, just Joe average, Jane average, walking down the road, or cliff face in this case, I don't know that they'd stop and stare. Maybe. So you see those giant beanbag sort of shaped things in there? Those are the pillow basalts. And these happen when there's an eruption underwater. Again, one of those fissure eruptions. And you have to be at a certain depth to have the pressure to pinch off these flows. So if you've ever had the pleasure of watching a rabbit's poop or a guinea pig, okay, you know how you get this little stream of pellets coming out, right? Well, that's because of their sphincter muscle. In this case, the water pressure serves as the sphincter muscle, if you would. So this water flows out. I also kind of picture a Play-Doh machine I used to have as a kid, and you'd squeeze down and you slice off these little bits as they'd come out, all right? The water pressure serves as that. And what happens is that these things pile up all around the vent underwater and just sort of build up this giant mound of pillows, beanbag. Like I said, if it was in the 60s where they found these, they probably would have called them beanbag basalts. But they went with pillow basalts. So, but you see these round things there. And again, this tells us that whether he is, in this case, up a cliff somewhere or at the shoreline, when these formed, this area was underwater. All right. Now, I'm trying to keep things simple, especially because I'm introducing a new topic that's fairly controversial, and that's talking about the age of the Earth and whatnot, and how long stuff has been there, and the fact that sea levels changed over the years, and so on and so forth. There is another option for a lot of these things, and that's called uplift. All right, a perfect example of this is, oh good God, I just forgot the name of the mountain. Everest. At the top of Mount Everest, you will find plenty of seashells. Okay? So, early folks, early humans, what was the first assumption we made? Fairly logical one, of course, is that, oh my God, water level used to be this high. And we got some flood stories out of that. Okay? However, the other option, and as we learned, the correct option is that, well, Mount Everest, the rock that's in Mount Everest actually used to be at the seafloor. There's some amazing pressures going on, and that's a fairly rare event, or unique event, I should say. Mount Everest is where India is trying to join the rest of Asia. So India is really cramming itself. Imagine a car wreck where the one car just keeps gunning it. All right, it's just really determined to blow through you. That's what's happening there. So we've just seen this amazing amount of uplift. I think they said in like the last 60 million years, which again sounds huge, but it's really not for something as big as Everest. So that was seafloor. All right, we didn't have to raise the water level that high. But in these conversations, fairly safe assumptions, because we're talking probably within, 10s, 20s feet, something like that. Unless this guy really is up a mile up a cliff. But, because that is a lot to ask for sea level change. But it's happened. Certainly happened. So just a little disclaimer there. All right, so that's the end of things you can make out of lava. There's more. I just picked a handful, half a dozen or so little neat things. That being said, I want to point out that this is splattery lava, okay? So we're still kind of under that, but they give it a new category because these aren't lava flows. This is that pyroclastic material we talked about way back. This is the stuff that spews out, that makes the real pretty pictures as long as you're far enough away. This comes flying out, and again, this is related to being really, really, really gassy, okay, for a volcano. Pyroclasts come in sizes, I think. I do not have a... I swear I did another upgrade on this because I had some of this stuff in here. Pyroclasts come in sizes of ash, A-S-H, ash, cinder, C-I-N, cinder, and block or bomb. Block or bomb. Ash, cinder, block, or bomb. What do you think is the smallest? Ash, good. And then blocks or bombs are on the biggest end, and they can be as big as they want. The power of these things is crazy. Again, from the St. Helens video, the one guy says, oh, my, those are as big as a small Volkswagen, perhaps. I don't know what a big Volkswagen is, but the point is that they're car-sized, and it's just tossing these around like it's nothing. So you don't really have an ending point. But ash is ash. I think we could all agree on that. It's only going to get so big. Cinders, I always picture like bonfire-size pieces, because we do often refer to that as what's left in there, those logs and stuff is cinder. And it's nothing where somebody's going to challenge you or anything like that anyhow. Your book will mention the shapes that they end up being, and I don't care too particularly much about that. Some of them are more streamlined, these for example, than others. And that is actually the difference between a block or a bomb is how, whether or not it was shaped as it was flying through the air. I guess if, you study that stuff, you are going to want to differentiate. But so pyroclastic material, again, pyro means fire, clasts are rock fragments. And this is stuff that doesn't flow gently out the side of the volcano, but because of the gas content, it's thrown up into the air and goes that way. Yes, ma'am.
You say bomb, like
So I get a story every so often. I don't always tell it, but I had one semester some kid raise his hand and said, "Did you say bong?" Like, yes, this is where bongs come from. They're actually naturally created. And, the different colors I can't really account for, but no, B-O-M-B. Yes. Thank you for allowing me to tell that story. It is a true story. You guys, I tell you. So these are probably both cinders, okay? And the penny there for scale. And I did, one of the things I thought I added was the actual diameters, a slide with the diameters in there. Not that I'd ever have you memorize it, but just so you can see. No? Well, no, that's the Lincoln Memorial there, I think. It is because it's on black. Yeah, that's a 1 cent. I could read it. And I just got really, really loud for the folks listening on headphones. Sorry about that. All right. So pyroclasts. And not a whole lot of time dedicated to them, but these things, I should really expand it here because pyroclastic material is what did Pompeii. I mean, it's just ash. Well, that was a lot of ash, okay? Has anyone been lucky enough to get over there? Every so often I get a student that's been. It's amazing. And they just recently uncovered, of all things, a market table where they had they felt 3 or 4 different hot food areas, and the archaeologists just going bonkers with their creativity these days. But it was all painted. The ash had actually preserved this for thousands of years. It was all painted bright colors, and they had these 3 different serving areas there, and it said it looked like it was even set up to maintain hot food. That's a bit of a stretch, but they're still excavating it. We're still finding out so much, and not just those poor people frozen and in position that you end up seeing. And they were literally, incinerated and refilled with ash. Amazing stuff. I'm going to look during my break for that part. I swear I fluffed up this with some pictures and stuff. And pyroclastic flow is another one that I meant to add. You don't need to put in there, but it did come up in the St. Helens video. It's an ash flow, okay, and again, kind of the level of what got Pompeii. Obviously, it didn't do that to the folks around St. Helens, but it's quite a mess. It's quite a mess. Okay, these are under gases, and that's how I know that this isn't the right PowerPoint. So this is under gases. Remember, we had lava, pyroclastic material, and gases. All right. But before we even do these last 2, what did we tell you was the number 1 gas that comes out of a volcano, in a volcanic event or an eruption? actually talked about it a couple times, not even necessarily in this chapter. Number one gas. Ooh. Nitrogen? No. Nope, not even. It's a compound, I'll tell you that. No. It's responsible for all the water we have on this planet. Water vapor. Water vapor, okay? Number one gas on that comes out. That's what all of that thick, billowing smoke, in quotes, is that comes out of a volcano. It's dirty water vapor. It's that ash built up in it. It just looks so dark and evil. But think about it, there's nothing burning in there. It's not. So it's just water vapor coming out. So the number one gas that comes out is indeed water vapor. And again, that goes back to the outgassing conversation that I'm pretty sure we had at some point in here about the source of the Earth's water and so on and so forth. All right. So now, two more that don't really have homes. That's kind of why I threw them under here, because one of these is a gas-related thing. The other one is just random chaos. Lahars doesn't even attach to a gas. A nuée ardente. Anyone take French in high school? Either one of you. Does that mean anything to you? Either of those words? Yeah. I said the same thing too. When I took Spanish, and they said, I want to take Latin. They're like, you don't need Latin. You're not going to be a scientist or a doctor. Little did they know. But I'd be a paleontologist, and it's all I talk about is Latin and Greek. I'm told this means glowing cloud, at any rate. And glowing cloud is by all means if Disney named it, because this is not nice and pretty at all. I prefer flaming cloud of death, and I'm not sure how you'd say that in French, but that's what these are. We mentioned we'd come back to talking about volcanic domes, right? And these domes, they seal off these volcanoes nice and tight, and I told you oftentimes it's worse because it'll lead to the mountain blowing off the side or so on and so forth, and everything crumbles down in it. It's a mess. Well, actually almost kind of worse, depending on the situation, is that a crack can form, be it the side of the volcano or in the dome itself, whatever. And all of these gases that have been building up underneath it just come out at once. It's again, pardon the word, but it's a giant volcanic fart, okay? And it is boiling hot, beyond boiling hot, because it's under pressure, so the temperature can get super jacked up. It's, if you look at the composition, mostly incredibly heavy gases, so it doesn't go up into the sky and glow. It comes up and boils down the side of the mountain. They've clocked these things at hundreds of miles an hour. They're just evil. They referenced one in the one video I showed you guys. They talked about one. He says your best bet is hopefully there's a helicopter waiting to bring you back up, straight up. He says, because you can't outrun these things. And these have taken out more villages than ash flows or anything else have. So there's boiling hot flows of gases that come flying down the side of a volcano, oftentimes hundreds of miles per hour. I don't have a nice, clean definition for it. I apologize, but nasty, evil things. So that's glowing cloud. If you were 5 miles away on another peak, I suppose it might look like that, but as long as you couldn't hear the screams. Lahars. It's not plural. It just is lahars. Whatever language it comes from, they could throw an S on it without pluralizing it. A lahars is a volcanic mud flow, and you heard a lot about these in the St. Helens video as well. They just didn't use the term lahars. Think about Mount St. Helens on just an average day. Think about any giant mountain. What's the whole top covered in? Snow and ice, glaciers maybe even, not so much nowadays, but a whole lot of snow, right? And then as soon as that hits, all that snow melts. So you've got this snow, and the snow's usually above. Again, I don't know how much you guys know your environmental boundaries and whatnot, but the snow's usually above the tree line. Once you come down the slope, you've got the tree line where you're going to have your soils and all the trees and grasses and whatnot, okay? So all that stuff almost instantly melts, comes flooding down the hill, picks up all that soil, the trees, whatever, plus you've got all the ash coming out and mixing in with this, and it is this nasty slurry of water, soil, ash that again comes barreling down the side of the mountain. This at least isn't boiling hot, but it's still quite devastating. So lahar is a volcanic mud flow. We've just got some random pictures now. This is a shield volcano, and again, just trying to illustrate the idea of how a sort of low profile, low slope, broad-based these things are. This has multiple vents. Again, just for our purposes, I told you we kept things fairly simple, straightforward when we drew them originally. But this one has a lot of feeder pipes, and that's fine. This is much more realistic. Especially when you're looking at, say, a stereotypical example, like one of the Hawaiian Islands, okay, where they'll talk about different fields. And those fields are obviously fed, they're miles away from one another. So there's this little pipe that goes out this way, a little pipe that goes out that way, so on and so forth. Cinder, again, by contrast. All right, they're trying to point out, very pointy. There's no measuring stick on here or anything like that. But again, these are significantly shorter. But still, if you were standing in front of one of them, it would definitely be imposing. Skyscraper size. Big, tall building size. I'm not necessarily a skyscraper, but certainly rather tall. The one thing I don't like about this is that they use the word lava on here. We taught you, and accurately so, that cinder volcanoes are primarily made up of pyroclastic material, okay, not lava flows. Mount St. Helens. So this is what happened with St. Helens. They're drawing this a little off center, but again, it may have been, the vent pipe may have been off center, but for whatever reason, it found it easier to go out the side of the mountain. And what would be really nice is if they had a fourth drawing in here that basically shows how, if you watch my mouse right here, basically all of this just crumbled down in, okay? And that's why it lost so many feet there. Good 300 feet, I think, or maybe it was a couple. I forget. I shouldn't say. It lost a significant amount of elevation. Go read your reports. I'm sure you guys reported on that. And it's also, as I said, why this was sort of a unidirectional event. It really just affected one area. If it had gone out the top, well, it would have been much more of a radius kind of thing. Okay, but it was definitely one-sided. I'm not sure why I keep this picture in here. Just a lot of billowy smoke, though. Okay, Wizard Island. We talked about Wizard Island in our caldera conversation. Remember I told you that a caldera forms, and we're actually going to show you that here. So here is your volcano, right? Got a couple vent pipes going there. Here's your magma chamber. And, hey, it's crazy. Let's have a crazy weekend party. Let's blow everything up. And boom, everything goes out. Your lava levels go down so much. The pressure goes down so much that after that eruption, everything's kind of just caved in, collapsed. You've got a perimeter ring still there, perhaps. But all that rubble, and what does that rubble do? Well, it blocks stuff up. All those old vent pipes are crumbled. They're filled with crap now, and so on and so forth. So it's just a big, jumbled mess. And you see your lava levels are significantly lower as well. But over time, and look, over time it's rained, so this has started to fill up with water, as we told you calderas quite frequently do. Well, one of those vent pipes, because this is still a pressurized system, one of those vent pipes found a way to the surface and started making a new volcano. All right? But as this volcano is surrounded by water and isn't too, apparently in the case of Wizard Island at any rate, isn't too horribly destructive, you end up with, well, the Native Americans way back when, standing on the shoreline in awe, probably saying, oh, wow, there's some crazy old medicine man, I'm stereotyping here, pardon me, but whatever, out on that island, some evil spirit, and you get your stories that way, until finally somebody takes a canoe out there, finds out what's really going on, and then maybe that's where, who knows, maybe where they go for special events and ceremonies and stuff, or I don't know what, but over the years, we've anglicized it, I'm sure, into Wizard Island. So it's active, it's still building, but it's certainly not, mean, nasty volcano that's going to take out a city or a town. It's picturesque, if nothing more, especially when it's doing its little eruptions and things. This picture's a bummer. The more you stare at it, the more you take in, the more you realize that, yeah, we talk about nice and pretty things, but the destructive power is unbelievable. This is the Caribbean area. I told you that the Caribbean, there's actually a fair amount of earthquake and volcanic activity going on. There's some microplates, smaller plates that are always moving around. This is a shoreline right here. These are docks. This was a road, which means or implies that these were all structures, houses, buildings, whatever. There's your volcano off there fairly far in the background. And this gentleman, whether he was out of town for the day or he's from a neighboring town, that's lost to the ages, or at least to my knowledge. But that village is certainly no more. And that is, probably a good bit of what Pompeii looked like before it was continually filled over and over and over with ash. Just devastating. And that is soufre air, as I say. And you know me, I never like to end on a down note. We're back to Disney now. I could certainly see this in the lobby of the Polynesian or something. It's very pretty, very picturesque. What's that black stuff? Basalt, more than likely, yeah. So you've got all this basalt here. You've got that fresh, it is a beautiful picture, is it not? I mean, color-wise, it's stark, and then you've got this beautiful yellowish orange in the center there. But yeah, this is out on a field somewhere, and I don't know, there's the Hawaiian Islands. They really didn't always care about as much about labeling pictures as they do nowadays. But it might have been referenced in the text somewhere. But at any rate, so a little baby volcano forming. All right, and I lied. There is one more thing to still see. You folks at home, I think I provide a separate link to this video. Yeah, it's not going to open here. I got to open it myself. So I'm going to leave it on. You probably won't be able to catch the whole thing, but please watch it in your own screen. Because I don't think I could resize my... What did I do? Well, why did it, of all things, why did it remember that? I'm sure there was a little, for lack of a better word, trick photography going on there. Even if it was using the sort of fisheye lens, you know, kind of the way what's the one you strap onto your head there, not a GoPro kind of lens. But impressive nonetheless, right? That is, however, exactly how two of the most famous volcanology people died. If you saw anything from National Geographic from the 90s or 80s, and I know you guys aren't that old, but any famous old video footage with people in tinfoil suits down by volcanoes, it was this husband and wife team. They everywhere that did for National Geographic. and I say luckily, just, because they were both killed at the same time at the same crater. But one of those things just splashed right up, and that was it. There's no burn unit for stuff like that. But luckily, we still have some mad scientists left in the world, be it folks that are willing to do this, folks that are flying into hurricanes and chasing these storms. We've got drones now. It would be interesting to see what we send our robots to do instead of us. We might get a little less brave. But there's some people who are always going to want to be there firsthand, so we still find stuff out because people are, willing to do that. And hopefully that'll continue. Because there's always people like me who are more prone to go to the library than to go climb a mountain. So I did my share, but nonetheless, not all research is done in the field. Like this crazy 18-year-old who climbed up on that boulder when I said, "Get down from there, you're going to fall." So, all right.